Tech Talks education, let us continue with the detection of anions in solutions. And in this case, let us go straight to the detection of chloride ion. Since we are done with the sulfate ion, let's go to the detection of chloride ion with this formula of capital C small l minus. So let us also look at a table just like we did for the sulfate ion in solution. So we have here test, we have observation, and then we have our deduction. Test, observation, deduction. The first test is still the use of lead to nitrate solution, in that we shall add a few drops of lead to nitrate solution. So lead to nitrate solution will provide the lead to ion that combines with the chloride ion to form lead 2 chloride, which is also an insoluble salt. So it will be formed as a white precipitate. You shall get a white precipitate of lead 2 chloride, and this one shows that there is chloride ion. So since we have got in this case chloride ion, let us see the reaction equation here. The equation for the reaction is the combination of the lead 2 ion with the chloride ion. Since chloride ion is having one negative charge, we have to make it to be 2, and then it will combine with this divalent cation, that's the lead 2 ion with 2 positive charges, and we get lead 2 chloride, which will be precipitated, formed as a solid, and we get a white precipitate, as we had seen later, earlier with sulfate ion. So this one is the reaction equation involved. Then let us proceed to the next test, that we need to add a few drops of lead 2 nitrate solution and heat the mixture. So when we add a few drops of lead 2 nitrate solution, just like we did here, we are going to get a white precipitate. We are going to get a white precipitate. Then the instruction further says that you need to heat the mixture. Now, we must know that this reaction leads to the formation of lead 2 chloride, which is an insoluble salt, which will be precipitated. Now, lead 2 chloride, if you heat it, it dissolves. On cooling down, the precipitate reappears. That means that it has a high solubility at a high temperature, and it has a low solubility at a low temperature. So we say we get a white precipitate which is soluble on heating. But we should also remember that on cooling down, it reappears. That means the precipitate reappears on cooling. And the reaction equation remains the same here. That the lead 2 ion of the lead 2 nitrate solution combines with the 2 chloride ion, since it is a divalent cation in this case, combines with 2 chloride ion, which is monovalent. It is a monovalent anion, and we get our insoluble lead 2 chloride, which will be precipitated. So it is that lead 2 chloride which dissolves on heating and reappears on cooling. So this one means that there is chloride ion. Let us go to another reagent that can also be used. Let me use this one as Roman 1, this one as Roman 2. We can also have another reagent that is silver nitrate solution. So we can add, let me be specific in this case, we are dealing with always 1 cubic centimeter of the solution under test. Just as I said, it is 1 centimeter length of the test tube. So that one is, it is just approximately 1 cubic centimeters. So add 4 drops of silver nitrate solution, followed by, that means then, not and, but later on, or then, or followed by the same number of drops of dilute nitric acid. So here, if we start with the silver nitrate solution, the reaction will take place in such a way that the silver ion of the silver nitrate solution will combine with the chloride ion in the solution under test and form a white precipitate. It will form a white precipitate of silver nitrate will be formed. Then, if we go ahead and add the dilute nitric acid, it will play the same role as we had seen earlier on with the sulfate ion, because it will destroy any carbonate ion or any sulfite ion, which would also form a white precipitate of either silver carbonate or silver sulfite, and it misleads us to think that the solution contains chloride ion. So in this case, if you add the dilute nitric acid, if the white precipitate is silver chloride which has been formed, then it will not be able to dissolve in the dilute nitric acid. So we get a white precipitate insoluble in the acid. So the reaction equation is just very simple. Before we go to the reaction equation, because we are going to look at the reverse of this, we just know that here there is chloride ion. So let me use dots here, because we have an alternative reaction or an alternative test whereby we now alternate, or we alter the order of addition of these reagents here. So we can also start with the addition of 4 drops of dilute nitric acid, followed by 4 drops of silver nitrate solution. So in this case, since we are starting with the dilute nitric acid, its work as usual we know is to open the way to destroy any sulfite ion or any carbonate ion and prepare the way for the action of silver nitrate on the chloride ion in that solution. So if you have added the acid first, then add the silver nitrate solution later on, you are going to get a white precipitate. And it is an indicator that there is a chloride ion. Now, let us see the reaction equation here. In this case, the reaction equation is that the silver ion, remember it is for both this test and that test, that the silver ion, which is a monovalent cation, it will have to combine with the chloride ion in the solution under test, and we get silver chloride formed. It will be precipitated or formed as a white precipitate. This is for your own consumption for the sake of theory. Then finally, let us go ahead and we have a look at our final test for chloride ion. So we are now going to Roman 4. We are not calling this one here Roman 4. Reason being, these are just the same reagents used for carrying out the same test, that is for confirming chloride ion. And in this case, we are just only changing. We are just changing the order of the addition of these reagents here. So finally, we can also add a few drops of silver nitrate solution, followed by ammonia solution. This is a test that may also be given that will make you be able to detect. It will make you to be able to detect chloride ion. In this case, when we add silver nitrate solution, we shall get a white precipitate. And then on adding ammonia solution, you will just add ammonia solution and this white precipitate will dissolve. So it is soluble in ammonia solution. And in this case, we are not going to talk about the color of the solution formed because we are not dealing with cations, we are dealing with an anion in this case. So it is a white precipitate soluble in ammonia solution, and this one means that there is chloride ion. We are not in this case going to write the equation for the reaction here. Reason being, the reaction leads to the formation of a complex ion in this case. So let us leave it alone, and it is always not asked for. So I want you to be able to see something here, that when we are detecting sulfate ion and we are detecting chloride ion, we use the same lead to nitrate solution and we get the same observation of a white precipitate. Therefore, when you have been asked to add lead to nitrate solution, a few drops of lead to nitrate solution to a solution under test, should you get a white precipitate, do not just write chloride ion, you also need to put what? Sulfate ion, because both of them gives us the same observation. The only thing is when you now come to the confirmatory tests, in this case, that is it, when we come to the addition of a solution of a soluble salt of silver, and in this case, followed by a corresponding acid with the same anion. That's when you can distinguish between these two, or when you are trying to confirm sulfate ion, that's when you can distinguish between these two. And remember that these tests here, they can give you these tests here, then they ask you to carry out a test of your own choice. So we expect you to give us either this test here or this test, you carry it out, give us the observation as you can see, and then the deduction. So thank you for watching. This is Step Talks Education. Thanks for watching us.